This project, titled The Effect of Movement on Temporal Order Judgment, using a robotic haptic device, aims to investigate the effect of active and passive movement on temporal binding window using the robotic device Haply Inverse 3. Previous research shows that active movements enhance precision in audio-tactile temporal order judgment tasks compared to passive movements conditions. However, it is still unknown whether active and passive movements executed at different speeds affect performance in an audio-tactile temporal order judgment, whether the execution of movements influences the localization of the spatial position where a stimulus is presented, whether there are any differences in performance on the temporal order judgment between adults and children, as well as between sighted and blind individuals. To fill these gaps in literature, we will conduct an audio-tactile temporal order judgment task in conjunction with active and passive arm movements. An auditory stimulus, a beep, and a tactile stimulus, a vibration, are presented in quick succession at variable temporal intervals, and participants are asked to identify which stimulus occurred first. We will use Haply Inverse 3, a robotic device that allows for continuous spatiotemporal tracking of movements and facilitates passive movements at varying speeds. Auditory and tactile stimuli will be delivered via a caterpillar attached to Haply. Sighted participants will be blindfolded during the task to eliminate visual input. In the passive movement condition, Haply guides the participant's arm in a passive motion, while auditory and tactile stimuli are delivered during the movement. The active movement condition is identical, except that participants execute the movement independently without any guidance from the device. Both the passive and active movement conditions are conducted at different speeds, either fast or slow. In the baseline or control condition, participants perform the task with their arms stationary. Finally, in both active and passive movement conditions, participants are asked to localize the spatial position of the second stimulus by returning Haply's arm to the corresponding position.